This is section 10.5, solving quadratic equations by completing the square. So this is another method to solve quadratic equations. That means to find out what x equals when y equals 0. So let's see what this means. You already learned how to factor a perfect square trinomial. Remember ax squared plus bx plus c? If we can manipulate or change a quadratic equation to make it a perfect square trinomial, we will be able to factor it. Okay? So let's look at how and when to do it. If an expression is in this form, x squared plus bx, all you have to do is add the square of half the coefficient of that x term. In other words, you're going to half b and square it, and then you will be able to factor it. So you take x squared plus bx, add b divided by 2 squared, and that actually becomes, when factored, x plus b divided by 2, the entire quantity squared. Okay, so what you have to do first is see if you can find the value of c that makes an expression a perfect square trinomial. So look at this example, x squared plus 5x plus c. So to make c the value for a perfect square trinomial, you have to take half the value of b, so half of 5, and square it to find c. So you would take 5 divided by 2 and square it. You get 25/4. So we know that c needs to equal 25/4. If c were 25/4, then you could factor the expression to x plus 5/2 squared. Because remember, you take the square root of the first term, the square root of the last term, and then square the whole quantity. You can FOIL this to confirm that it is correct, that it does work. So if you take x plus 5/2 times x plus 5/2, you get x squared plus 5/2 x plus 5/2 x plus 25/4. And when you combine those two middle terms, you get x squared plus 5x plus 25/4. That's what we had at the beginning. So that is a perfect square trinomial, and it does work. Okay, so remember this. To factor a perfect square trinomial, you have to take the square root of the first term and the square root of the second term and add them together if bx is positive, or subtract if bx is negative, and then square the binomial. That sounds complicated, but it's really not. Okay, let's try to find some more c's to see if you can do it. X squared plus 8x plus c. We need to find c. So you take half of b and square it. So half of 8 is 4, squared it's 16. So we know that c must be 16 to make that a perfect square trinomial. If that polynomial is x squared plus 8x plus 16, you could factor it to x plus 4, the quantity squared. Then you could solve it, right? Because you would set the parentheses, the equation in the parentheses, equal to 0 and solve for x. Here are more examples for you to try. So you should pause this and try to solve each one. Good luck. In the first one, the b term is negative 12. Take half of negative 12. Okay, so we're going to take x squared minus 12x, and then at the end, we're going to add half of negative 12, that's negative 6 squared, so we're going to add 36. Okay, so c equals 36. Now, if you were going to factor that, remember, because that 12 term is negative, right here, it's negative, when you factor that, it's going to be x minus 6 squared. Okay, in the next one, take half of 3 and square it. So it's going to be x squared plus 3x plus 3/2 squared, which is 9/4. Okay, c is 9/4. Again, to factor it, you take the square root of the first term, the square root of the last term, add them together, square the whole expression. In this one, you need to take 7, right? Cut it in half and square it. So I think you can calculate what c is. It's x squared, okay? We're going to add 7x, keep that term the same. But our c now becomes 7/2 squared, which is 49/4. All three of these are now perfect square trinomials, and they're very easily factorable. That's why we're doing this, so we can factor them and solve it. Okay? So here's the key point down here. A perfect square trinomial can always be written like this: a plus b squared or a minus b squared, where a is the square root of the first term and b is the square root of the last term, and then you square the whole thing. If the term in the middle is negative, then you need to put a minus between the two terms. You can use this method to solve any quadratic equation, but to begin, you always have to write the equation in this form. It's x squared plus bx and set it equal to d. You have to put the constant on the other side. Because remember, we can't just add a c and not change the expression. Okay? It's fine that we can calculate a c, and we did that already, and that was great. But now we're working with equations, and if you're going to add something to one side, you have to add it to the other. So look at this example. If we want to solve x squared minus 16x equals negative 15 by completing the square, the first thing we have to do is find c. Take half of b and square it, and add that number to both sides of the equation. So half of negative 16 is negative 8, squared at 64. So we're going to add that to both sides. X squared minus 16x plus 64 equals negative 15 plus 64. So the equation has not changed because we've kept it in balance by adding 64 to both sides. To solve it, factor the left-hand side. So we factored it. It's a perfect square trinomial. It makes it really easy. It's the quantity x minus 8 squared, and that equals 49. Take the square root of both sides. This is what you did in the previous section. We solved square roots, right? So we're going to have x minus 8 equals plus and minus 7. Remember, you need to use both the positive and the negative case. So when you add 8 to both sides, to isolate the x, to solve for x, you get x equals 8 plus 7 and x equals 8 minus 7. So x equals 15 and x equals 1. You can always check your answers by substituting them back into the original equation. Here's another example. X squared plus 6x equals 7. Solve it by completing the square, right? Take a half of 6 and square it, and add that to both sides. So we're going to take a half of 6, which is 3, square it, it's 9. Then you factor it. You know the left-hand side is a perfect square trinomial, so it becomes x plus 3 squared, and the right-hand side is 16. Take the square root, so it's x plus 3 equals plus and minus 4. Subtract 3 from both sides, so x now equals minus 3 plus 4 and minus 3 minus 4. So x equals 1 and x equals negative 7. If the equation is in standard form, remember what standard form is, ax squared plus bx plus c, or in this case d, you have to get that constant on the other side. So you have to change it to ax squared plus bx equals d. Always move the number over to the right-hand side. So if we're going to solve this one, and this is probably one of the more difficult problems, you take 2x squared plus 20x minus 8 equals 0. The first thing we need to do is move 8 to the other side. So we have 2x squared plus 20x equals 8. It's now in the form it needs to be in. We need to find c now. Add half of d squared to each side. So we're adding 5 squared to each side, which is 25. X squared plus 10x plus 25 equals 4 plus 25. Factor the left-hand side. It's a perfect square trinomial, so it's x plus 5 squared, and that equals 29. When you take the square root, you have a positive and a negative case on the other side. So x plus 5 equals positive the square root of 29 and negative the square root of 29. To solve it, subtract 5 from each side. So x equals negative 5 plus the square root of 29 and negative 5 minus the square root of 29. So using a calculator, you would find the solution. It's both 0.39 and negative 10.39.